Hi everyone, it's Math with AUB. Let's continue our journey for the new book of second exercise 3.2. Let me write part 2. I have forgotten to write. Yes, still base making questions, simple ones. Some good ones, but simple ones. Let's evaluate definite integral minus 1 over 2 to 3 over 2 x minus cos pi times x, that is dx. Still, it falls in the vicinity of simple integration. Simple integration. Integration of x is x over 2. Integration of cos is only sine pi x. Angle is multiple of pi, dividing by pi and putting the limit. It is simple integration because we are in a position to multiply this integral and dx with each and every term without any difficulty. It's simple one. It's simple question. Simple. If we are in a position to multiply this integral operator and dx throughout each term, it's known as simple integration. It is the case x dx minus cos pi x dx, keeping the limits intact, minus 1 over 2 to 3 over 2. Integration of x is x square over 2. Enhance 1 in the power dividing with the same power. Integration of cos is only sine. Angle is multiple of pi, dividing by pi plus c. Putting then upper and lower limit, writing upper and lower limits. Now it's put limits, upper limit minus lower limit, upper limit minus lower limit. That's the way to put limits. Upper limit minus lower limit. What is upper limit? It's our 3 over 2. Let me write 1 over 2 same. Instead of x, let me put 3 over 2 here, minus 1 over pi sine pi x is r 3 over 2 plus c. That's our upper limit. Minus, writing lower limit same, 1 over 2. Instead of x, minus 1 over 2 is square negative sine pi times x is r minus 1 over 2 dividing with pi, or writing 1 over pi in that style. Let's see. The square of 3 is 9, square of 2 is 4. We have something like 1 over 2 times 9 over 4 minus 1 over pi. Value of sine 3 pi over 2. Value of sine 3 pi over 2, it falls in third quadrant. Its value is minus 1. One can check with calculator as well. Let's see. That's the domain of the upper limit minus lower limit. 1 over 2. The square of negative 1 over 2 is positive 1 over 4 minus 1 over pi. Sine is an odd function. So, negative sign in the argument is not going anywhere. Negative sign in the argument is not going anywhere because it is odd function. It should be kept intact and it will become minus times sine pi over 2. Sine negative pi over 2 is equal to minus 1 plus see. Sine negative times pi over 2 is equal to minus 1, or writing negative sign outside, sine pi over 2 is equal to 1. Sine 90 is equal to 1. Everybody is familiar. It will become 9 over 8 minus plus 1 over pi plus c. Here 1 the 1, 2 for the 8, but negative. It will become minus plus, owing to this minus, it will be again negative 1 over pi negative c, 1 over pi negative c. The c cancel out. 1 upon pi, positive negative cancel out. We are left with 9 over 8 minus 1 over 8. 9 over 8 minus 1 over 8. 9 over 8 minus 1 over 8. As denominators are homogeneous, write one time, no transition in the numerators. It will become 8 over 8, it's equal to 1. 1 is our answer in that case. Let me check whether this step is visible or not. If not, let me clarify. Then it's clear, visible. Okay. Question number 2. Good one. Good one. A mind boggler type, but simple enough. You should have some familiarity with from differentiation. What is the differentiation of root x? It is 1 over 2 root x, 1 over 2 root x, 1 over 2 root x. If you have this thing in mind, then this question is simple enough for you. Let's see and find out how. Okay. Question number 10. Our limits runs from 1 to 4 cos root x divided by 2 times root x dx. It is simple integration. And let me invite you to differentiate sine angle root x. Then you have good idea about this question. Integration of sine, differentiation of sine is cos, keeping angle intact, and differentiation of sine is cos, keeping angle intact. Then differentiation of angle is 1 over 2 times root x. 1 over 2 times root x. So its integration must be sine root x. If still you are facing some difficulty, then take supposition y is equal to root x. Differentiate with respect to x, dy over dx. I used to teach students how to differentiate root, square root. Whatever is in square root, write 1 over 2 times square root. 1 over 2 times square root. 1 over 2 times square root. Whatever lies inside the square root, its differentiation must be written in numerator. It will become 1 over 2 times root x, or one can go to simple strategy, x 1 over 2, drag the power down, make the power coefficient, subtract 1 from the power, and differentiation of x is 1. Turning the exponent from negative to positive, let me write in denominator, it will become positive. Instead of 1 over 2, let me introduce root x. Whatever trajectory you want to follow, just follow. You can. But I invite you, root x is, differentiation is given by 1 over 2 times root x, and differentiation of x is 1 here. So suppose root x is equal to y is equal to root x, its differentiation is equal to, solving for the differential dy, shift dx here, they put both values here, it will become 1 to 4 cos y. Instead of this overall figure, we have dy. Now look at this. Now you can look through it. It is transparent like glass. To see through it, it's simple cos. Integration of cos is only sine. Then limit. Before putting the limit, you should go to the given variable, that's x, and we have assumed that y is equal to root x. Instead of y, we can plug in root x plus c. Now upper limit minus lower limit, the definition demands, sine, our upper limit is 4 plus c minus sine root 1 plus c. Square root of 4 is 2. It is our sine 2 plus c minus root of 1 is 1. It is sine 1. Positive, negative times positive, negative. C cancelled out. We have sine 2 minus sine 1 as final answer, or one can use the calculator to arrive at the values of this one, sine 1 and sine 2. Cool. Question number 11. That is sine x cos x dx. It's simple question, simple enough. Whatever you want to do, just do with that. Look at this. Limit runs from pi over 6 to pi over 3. We have sine times cos x dx. I used to chant the slogan that function derivative works wonder. Function derivative. Differentiation of sine is cos. Function derivative. Function and its differentiation. Just add 1 to the power of the function, dividing with the same. It's our cool integration in that case. Function derivative situation. Function derivative enhance 1 in the power of the function That's sine 1, sine square over 2 plus c. Upper limit minus lower limit to be the task to be put. We have upper limit minus lower limit. Simple as that. Let me write 1 over 2 in that style. Sine value of x is pi over 2, pi over 3, whatever the value is, just square. Plus c, that's our upper limit, minus 1 over 2 sine, our angle is pi over 6 square plus c. If I'm not wrong, sine pi over 3 sine 60 is given by root 3 divided by 2, square is there, plus c, negative 1 over 2 sine pi over 6, 30, sine 30 is 1 over 2 square to be intact, plus c, 1 over 2, it will become square of square root 3 is only 3, square of 2 is 4, plus c, minus 1 over 2, square of 1 over 2 is 1 over 4, plus c, it will become 3 over 8 plus c, and it will be 3 over 8, it will be 1 over 8 minus c cancelled out. We have 3 over 8 minus 1 over 8. Again, denominators are homogeneous. Let me write again this step, 3 over 8 minus 1 over 8, if I am not wrong. Denominators are homogeneous. Write denominator one time. It's 3 minus 1. It will be 2 over 8. Applying table. 1 over 4 is our final answer. 1 over 4 is our final answer. 1 over 4 is our final answer. Again, I am forgetting. Let me demarcate a line to check the angle. It's good one. Okay, cool. Question number 12. I have told you several times that was function derivative works wonder in integration at your second year level. What is next? Limits are pi over 6 to pi over 2. I have 1 plus cos theta divided by theta plus sin theta whole square d theta. Look at this. Not to look odd. Differentiation of theta with respect to theta is 1. Differentiation of sine is cos. That's the function derivative situation. However, function is present in the denominator. Whenever function is present in the denominator, we have two possibilities. Number one, if it has overall power 1, then it is the case of ln. I have told you several times, differentiation in the numerator, function is in the denominator having overall power. It is situation of ln. Otherwise, we shuffle the function in numerator, changing its part from positive to negative, positive to or negative to 1 plus cos theta d theta. Try to hunt this question. This is our function, this is our derivative. Without taking any assumption, its function, it's our derivative. How? Differentiation of theta is 1. Differentiation of sine is cos. Function derivative. Just add 1 to the power of the function. That's our integration in that case. Theta plus sine theta minus 2 plus 1, it is minus 1. Dividing with the same power, then put limits. Upper limit minus lower limit. Upper limit is pi over 2. Lower limit is pi over 6. It can be written as negative 1 over theta plus sine theta overall power 1 plus c. Now put limits, upper limit minus lower limit. Let me write ul instead of upper limit minus lower limit. Putting values, minus 1 over theta is pi over 2 plus sine pi over 2. That's plus c. Upper limit minus 1 over negative theta means pi over 6, lower limit is pi over 6 plus sine times pi over 6. Sin pi over 6 plus c. Okay, let's negotiate the situation. Sin pi upon 2 is 1. Sin pi over 6 is, I think, 1 upon 2. Yes, we have just done. Sin pi over 6 means 1 over 2. Here is also, yes. It's equal to 1 over 2. 1 over 2. C cancelled out. What remains? Just see and find out. We have something like it is negative 1 over pi over 2 plus sin pi over 2 is 1 plus c minus, it will become minus 1 over pi over 6 plus sin pi upon 6 is our 1 over 2 plus c cancelled out. The rest, use the calculator. Whatever the result is, just write down. If I am not wrong, it is something near about approximately 0.66 or little less than that. It might be, if I am not wrong, let me recall. Yes, 0.558 your answer. Just utilize the calculator. I have calculator but no battery in my calculator. That's why I am leaving this as your assignment work. Please complete this. This is your assignment. As I have calculator but not battery in it. Okay, cool. Moving towards final question. That has good trigonometric ratios. Sec plus 10x over all square, and the limits are almost symmetrical. Negative pi upon 4 to positive pi upon 4. Like as this, negative pi over 4 to positive pi over 4, sec x plus 10x over all square. Look at the power, inspect the power, it's simple one. We are in a position to expand this without any trouble. It will become a square twice first into second square of the last. That's our dx. Sec x. A square twice a into b, 2 times sec x tan x, that's tan x square. We have sec square x, 2 times sec x tan x plus tan square x dx. As far as I myself is concerned, your books lack the trigonometric integration. Your book lacks the data or questions on trigonometric functions integration, on integration of trigonometric function. That's why you are going to face trouble. But let me give you a hint. Ask yourself, is it differentiation of something? Yes. It's differentiation of 10. Good. Its integration is 10. What about this? 2 times sec x tan x. Sec x tan x is differentiation of sec. It is differentiation of sec. So its integration is sec. Integration of sec square is only 10. Why? Because differentiation of 10 is sec square. Sec x tan x is differentiation of sec. So its integration is only 10. Its integration is only sec. What about this? Ask yourself, tan square is not differentiation of any function. Then we are in a position to convert this one into sec square. Tan square is given by sec square minus 1. Then we are in a position to answer the question. These are the functions, these are the special functions, and are the differentiation of some function. That some function is our answer in that case. Negative pi upon 4 to pi upon 4. We have sec square plus 2 times sec x tan x, and tan square is sec square x minus 1 dx. Sec square, making life simple, add them. Minus pi upon 4 to pi upon 4. That's our 2 sec square plus 2 sec x tan x minus 1 times dx. Now we are in a position to integrate all this complete. Sec square is the differentiation of 10. So its integration is 10. To sec x tan x, its differentiation of sec. So integration of sec and tan is only sec, while 1 is the differentiation of x. So integration of 1 is x. We are going to have 2 times tan x. It's 2 intact. Sec x tan x integration is only sec, and integration of 1 is x plus c. Now putting the limits, symmetrical limits from negative pi upon 4 to positive pi upon 4. Okay, cool. Just put limits and say goodbye. Upper limit minus lower limit. That is, upper limit is pi upon 4. Pi upon 4. It's somewhere else. That's pi upon 4. It's our lower limit. 2 times tan limit is pi upon 4. First upper limit plus 2 sec limit is pi upon 4. Minus x is our pi upon 4 plus c, that's our upper limit. That's our upper limit. Minus lower limit. 2 times tan negative pi upon 4. Lower limit is negative pi upon 4 plus 2 times sec negative pi upon 4. Negative value of x is minus pi upon 4 plus c. Now very gently solve this. Tan 45 is equal to 1 plus 2 sec pi upon 4 means 45 is only root 2 minus pi upon 4 sec plus c. That's my upper limit. What about lower limit? Look at this 2. Tan is also odd function. Tan is also odd function. Tan is also odd function. So negative pi upon 4 is equal to negative 1. Negative 1. 135 or negative 1. Negative 1. It leads to negative 1 owing to this symbol. 2 times minus 1. Sec is an even function, however, minus automatic vanishes, plus 2. Sec pi upon 4 is root 2. Negative, negative, positive pi upon 4 plus c. Just simplifying, just multiplying this minus, and let's see what remains. 2 plus 2 times root 2. Negative pi over 4 plus c minus, it will become plus 2. It will become minus 2 under root 2 minus pi over 4 negative c. Negative c cancelled. Negative c cancel. We have 2 times under root 2. 2 times under root 2 cancelled out. 2 plus 2, it's our 4 minus pi upon 4 minus pi upon 4. Let me write, then compile. In that case, denominators are homogeneous. Write one time. Take LCM. What remains? It's our answer. 4 minus 4 is LCM minus pi minus pi. Denominators are homogeneous. No change in numerators. 4. It will become minus pi minus 2 pi over 4. Applying table. We are left with 4 minus pi over 2. 4 minus pi over 2. It's our final answer in that case. It's our final answer in that. It's my tiny effort for you guys to give you idea about the trigonometry, especially about limits. Your book lacks trigonometric integrals. I will give you an additional some questions to give you good idea how to solve trigonometric functions, whether they have powers even or odd, mixed powers or whatever the case is. It's all by itself next.